because we are merged now. So let's start. Today we will be learning to do some circuits in Tinkercad, and we will do it gradually using very simple examples. But when you go for the lab, actually the lab, you would feel like it's a kind of advanced because it should have been later this week. The lab will be a bit ahead, but you will be still able to catch it. I'll make sure of that. So for the Allied students, actually the lab was for Thursday, and for us it was on Tuesday. But I think we all are going to have the lab the same day. I don't know how the lab is arranged for them. It's with the engineer, but we will see. We will see how we can catch up with the lab and with the Tinkercad circuits also. Let's start. Doesn't want to move? Okay. So the first experiment, let's start right away with the experiment. We will be connecting few LEDs in the breadboard, and connect it to the Arduino board. And we will do some symbol codes, and we'll make the whole system work. So this is how it will look like in the lab. We will have the same setup in the Tinkercad. So you see, you will have the board, and you will be doing some connections from one side of the board where you can see numbers up to 13. And even in the board, you can see some minus, yes. So those are for the analog kind of applications we will see as we do. So they mean something. They work as the digital pin, but if they have it's not the minus actually, it's having a tilde. But when it comes in the board, it looks like a minus. Tilde means the line with the small curve, which you can find above. It's like a small line, but curved. So that's how it should have been. But in the board, you can see it as a minus. And you will be having resistors, and you'll be having lines like this. The red means the VCC line, and the blue, sometimes it would be black, it would be the ground. And we will be connecting LEDs and wires from the digital pins. We'll see how it's done. Let's go for it and see. Tilde is for analog applications. We will see that how it's coming. When we come to the examples further, we will have to use those pins with the minus or the tildes. We will see it. So this is the basic thing, or how your Tinkercad would look like. You see, we will have a circuit, the Arduino board, and some LEDs, some resistors, and we will be doing code alongside. Because without code, the board doesn't know what to do. So we will have to do some coding. So can you log into the Tinkercad? And let me show you how to do that. We will do not everything, but some in between, because we have to catch up to the last. You can practice later as well. And if you face any difficulty, just let me know. So you can search for Tinkercad. And in this plus, if you click on it, using the circuits option. And in the right, you can find many of the components. We need the board, the Arduino, R3, and you can just click it and put it. And now it's kind of covering it. No, we have to keep it this way. And you can make it shrink or come expanded by just moving the mouse over it, or your two fingers. So can you place the components and see if you can reach up to here? Okay, so after doing this, I'll just give you the initial setup, and we will follow the slides again. You see, we have the 5 volt down. We can't see the 5 volt in the up. So what we usually do is click, and you can leave the mouse. The line comes along with you. So just try to do this connection where you connect the 5 volt. When you are straight, you get the blue line, you see? And you can connect to the 5 volt. Usually 5 volt, it's marked with the red. So you can go up here in this tab and make it the red color. And also you have the ground. So you have the ground, and you can click that and connect to the near to the black line, but make the ground black color. So that's the common notation for it. And you can also connect the ground of the lower line to the ground of the line. Same way for the red, like it's just, okay, now I'm seeing the wonky dunky connection. Yes, you can still click on it and make it straight like this. So just do this much. Remember, for the VCC or for the 5 volt, we usually put the red. For the ground, we put the black. We'll do one experiment, and then 2 of the others we will just watch. So until here, you are done. Let me wait for a minute, and we will go for connecting the LEDs. So if this is done, that's the first step you should always do. Connect the ground to ground and the red line to the 5 volt. Now, yes, I'll just put back to this diagram. So in case if you want to do it, so this is how the circuit diagram would look like. You will place the 3 LEDs. You can change the color of the LEDs. So keep the 3 LEDs and 3 resistors. Now, yeah. Well, okay, for this line and this line, because that's like you connect the, it's not needed. If you need, you can just directly connect to the pins of the board, like here, instead of doing how, okay, you're asking about the top line, because sometimes we need to make connections to the upper line. Like if you want to do this, okay, let me put the resistor here. So suppose I'm having something here. Instead of taking a wire and connecting to here, you can even connect it to this side. It's shorter. This is longer. So that's like for the easiness of the connection. We are just like making the red line 5 volt, the black line ground. That's it. So if you have some circuits on the top, you don't have to use longer wires. You can use the shorter wires. It's just like a process. Later we will see we don't have to do this all the time. Sometimes we don't need the top line at all. We just need the bottom line. So after you connect the 3 LEDs, you can just change the color, showing some basic circuitry things. So you can click here and, I'm sorry, not that. You can change it here, like the yellow here. Then you can make it green or any color that you want. And you see, if you drag in an LED, one pin, it's like a bit longer, and the other pin is a bit shorter. So the longer pin is called as the anode. It's like a bit out of the line. It's not straight. So it's just like out, and it's the positive, it's the anode. And the shorter one is called the cathode, and it's the negative one. So that's what we will see later in the slide. It's there in the slide and it would be explained. So for now, just drag the breadboard, and connect the VCC and the ground, VCC and the ground, and the 3 LEDs. And we're going back to this. You see the positive of the pins. Positive means the tilted leg is connected to the 3 of the digital pins. You can select any of them. And it's not the negative side, it's not grounded directly. You can still do it. But when you go for the lab, you need to keep the resistors so that the LED doesn't burn out. So this is for the safety. So you give the signal or the digital output from the pins, it goes through the LEDs, flows back to the ground. So here we can connect like this. Okay, you can take any. So this to the positive. So 12 to the positive. This to the positive. And you can drag the resistors. While you drag, you can see that you can change the resistance value. Suppose I put like 100 and make it ohm. You can see the change in the color. And can even tilt the resistor here. It goes anywhere around. Resistor, you can connect like this can be the top, this can be the bottom, or anyway, it's having no problem of the positive or negative. There is no polarization for the LED. I'm sorry, for the resistor. So you can connect it the left or right. There is no rule. It's not polarized. So you can connect it just like this. This whole line is connected. So even if you put a bit up, it has to be just connected to the ground. So you can put it like this also, like make the circuit complex and still keep it like this. Like take a wire, put somewhere, put the resistor there, and then connect to the ground. But it's kind of complex. So let's just grab the resistor, put it connected to the ground like this. You have seen these things before. So it's kind of familiar to you, I hope, to do this basic connection. So now we are done with the connection, and here we are. So we have to tell the board that you have to do something, and how do we communicate with the board? By doing the coding. So you see, here we have the 12, 11, and 10 pins. We have to say that these are the output. These are not the input pins. We are going to configure or set it up as the output pins. So you see what's the name of the first? Void setup. And in this set of code, void setup, pin mode, output, like which pin is output or which pin is the input, you give it in the void setup. Here we use 3 pins. And we have to say what is it like an input or is it like an output? So that would be the first set of the code. You do the void setup. Now, after doing the setup, I'll wait for a few minutes for you to type in. And also I will share this PowerPoint better so that if you can copy paste the code, we can move forward in the class. So let me see if I can export it as a PDF. Save as PDF. And I'll put in the Blackboard right away. This 325 PDF. I'll put it in the Blackboard right now. So you can understand it now. Don't waste time by typing, and you can copy paste and see your output. Don't tell me it's stuck. So much of things are open. Okay, it's here. Oh, Blackboard is here already. I'm sorry, I didn't see that. So let me make it big. Okay, so you can copy the code from there. For now, just listen. That's better. We will listen here and then we can do it. So we will have the setup. Setup means we will set the pins as input or output. There is some other options also. For now, we will just deal with the input or output. We set it as input or output. Now in the loop, how do we define like what is the function happening? We define it by the way, void loop. And you have this open bracket, close bracket. And what function you do is defined in the curly bracket. So how do you start? You give a delay and then you make the pin output at 12 high. Give a delay, make the 12 low. Then make the output or the pin 11 high, 11 low. So in this, you will define the delay. Now, 400 means 400 milliseconds, ms. It's the unit here, it's in milliseconds. So if you copy paste this code, I have it open here. See the multiple ones. Yeah, it's this one. So after you do the circuit, I'll give you 5 minutes. You can copy paste the code and I will give you time to do it. So you will do the circuit, you will give the code here and you can start the simulation. So as you said here, 12 is high, then the 12 goes low. What is 12? It's the red LED. So red LED becomes high, red LED becomes low, then the next one, which is connected at 11 becomes high, then it goes to low, 10 is high, 10 is low. So it follows the pattern with what delay? 400 milliseconds. So this is one setup, the basic one. We can have many features in here according with the code. So if you can just try to open the PDF, I hope it's copyable. And just try to do this one. For the next few, we will just watch. You can do later. So can you try to do this one if you have your laptops? For the students joining online, uh, do you have your laptops? Are you able to do?
Yes.
Okay, so from the next class also, we are going to do the similar kinds of questions. So please try to have your laptop and we will possibly do such kinds of questions from now to the end. So you are supposed to have. I hope if you don't have, you will carry it with you from the next class. So just if you have any doubt, just ask me. Just you can raise your hand or you can unmute and speak. Okay. So did you try to do it? You can see the LED blink, the LEDs blink. I hope, yes, you can do it. Are you able to do it? Okay. You can copy from the PDF. Okay, so this is okay. We can stop the simulation once we are done with it. And you can see that this is like the power supply to the board. Once we start the simulation, like this comes in and your circuit starts working. Girls, you can do it. Fine with you, Halima.
Doctor, we've mentioned that students since they have merged from Alim and then in asked that the same of Blackboard.
The students from Ali, they are joining. The students from Abu Dhabi, they have to be included. Was that your question?
My question is, you said that students from Alim are also in teams with us on the same team channel.
Yes, in the Blackboard. Yeah, that's based on the code that we did there. So it's like the same delay, like 400 delay, turn on. 400 delay, turn off. Milliseconds. The unit here is milliseconds. So now then let's go back to the PowerPoint. So we did this one, like we are controlling multiple LEDs using the Arduino's digital pins. You see in the PowerPoint, in the picture, you can have the digital pins and also you have the analog and the power. But from power, we take the 5-volt and ground. And here we are controlling the LEDs using our code, using the digital pins. So this is one of the simplest one. Now, just explaining the code, like the setup means we are setting up the pins as input or output. And then we define the loop. Loop means the function of the code. How does it or what does it do? Like it starts with the delay, then it makes the pin 12 high. Again delay, 12 low. Delay, the 11 goes high, then 11 goes low. After the delay, the 10 goes high, 10 goes low. And after this, it's the loop. So it goes back to the 400 and comes down. So it's a loop. So that's why we define it as the loop. It's the loop, how the loop functions. So again, a bit of explanation for you to make it clear that this setup function sets like what the pin should be. Is it an input or output pin? And this is how the loop works. So we will define the loop. So this is the start of the loop and it runs repeatedly forever until you hit the stop button. And what's the unit of the 400? Milliseconds or 0.4 seconds. So this is again the explanation. Turn pin 12 on, wait for milliseconds, pin 12 off. And that continues, and again, the loop starts. Now, always for such questions, you
Doctor,
are, yes.
so I added the code. The LEDs are supposed to be blinking
Yes, so let me show you how it would be if you
because it's
can,
not working for me. I don't know why.
again,
It's not working for me. I don't know why.
can you check the code? Because, and you have to start the simulation here. Only if you,
Yeah, I already did, but like nothing happens. No
can
error
you,
in the codes,
can
but nothing is happening.
okay, in the Blackboard, I have posted the material, the lecture 04 IoT updated. So in that, you can have the code and you can copy paste it and see with your code what is wrong. So you will have to practice some time after the class so you become familiar to what you're doing. Maybe it's the first time. First time it's supposed to be. So just practice, and even if you face difficulty, just let me know. You can let me know in Teams. And if you still have difficulty after the class, we will have a meeting and you can share the screen and I will help you. Just let me
Okay,
know.
I'll check now.
Okay. So this is for circuit, and always for such, we will have to draw the state diagrams. And the state diagram starts with this black dot. So this is showing the initial start. And it goes to the first state where your pin 12 is on, the others are off. And after the 400 milliseconds, you have to put it here. It would go to the next state and it continues and goes back to the initial one. So you will have to also draw the state diagram for such questions. And we will see the real questions later. So this is just like preparing for you for the big one. Now, this digital write, I hope you saw it, like in the code, digital write. What does it do? It sets that pin to the high or low based on what is written inside. So here we will say digital write pin, the number that you want to. Here we will put 12 or 11 or 10, and then we will say if it is high or low. The same with what we saw here, just giving you the guidance. Now, this one, where do we use? In the void setup. To set up, well, digital write, we put it in the void loop to make that pin high or low. Again, we are seeing the code again. Let me make it a bigger. So you see, this is how our code looked like. Void setup, we set the pins as the output. We say the number of the pins. This is the pin number. And we say the loop, like what should happen in the loop. Starts with a delay, then make. Digital write means make that pin high. Digital write, make that pin low. But you see here, we are saying delay 400 again and again. But we can define it as a variable. Like we call it as an integer, and you can add any name. Like you can say waiting period or waiting time. This is the name. And you will define the number here. It's like we do in normal coding. Instead of saying the number here to make it like look like the standard one, you define it early. It's the same thing, but you can define it as an integer before you start the loop and just say it by the name, waiting or waiting time or delaying time. Is this okay? So we can define it this way or in the right way. Both are fine. But when you go for the big problems, you will possibly be using this integer value of definition and then calling it by the name, what you define here. It's okay? Okay. Now, this is again to say to you that this line, each of these lines, they are connected. And see here, this metal. So this is like this side. So all these lines are connected like this. Well, inside they are connected as in the picture, as in the metal bars. So I hope this will guide you, like make you remember it again, how we deal with the breadboard. And revision again, the longer leg is the positive, the shorter leg is the negative. And for the first problem or the first question, we were connecting the positive to the pins and the negative was connected not directly to the ground, through a resistor to the ground. Is that okay? Now, a very simple example. In the first example, we dealt with 3 LEDs. Now, we will just use one simple LED. And this is like the name that you should know while you do with the first few problems, LED blink. So by the end of this class, you will know, that is LED blink. So LED blink means one LED. The first problem was LEDs blink. Now we will just have one LED and you will feel like, this I already know. So let's see, LED blink. Example 2, LED blink. And usually for any question, we will have to do 3 things: state diagram, code, and the circuit implementation. So this is what you should do in the problem. So what is it? Initially, the LED is off. After 1 second, you want the LED to be on. After 1 second, you want the LED to be off again. And this continues. But what is the initial state? LED off. And we have 2 states. So the simple circuit again, we connect the 5 volt to the red line, the ground to the black, and this LED I'm connecting to 13, and this short leg through a resistor I'm connecting to the ground. You see, this makes sense to you now because you saw the big one. You want the 13 to be set up as a output pin. So pin mode 13 is the output. So your signal comes from here. The green line goes through the LED and comes back to the ground. So that's how the flow happens. But how do you tell, like how to blink, when to blink, how much should it wait? Using the loop function or the void loop. So you will say, okay, the digital write, the 13 has to be high now. I can define it as low because it starts with the low. So how do I put this low and high? It has to be high here actually. So this can be anyway, depending on your state diagram. Now, can you do this very simple thing? And you can have to. I want you to do it in the 13th pin. And we can see something blinking within the board here. It's the simple one. Yes? In the exam, we will usually draw it. Okay, so as far as I know, you usually draw hand-drawn diagrams, which we will see later. But it's, if you know this, you can draw the other one also. So the basic thing is knowing this. These are baby questions. This is not going to be asked for the exam. This is preparing you for the big one. So yes, we will discuss that too. But for now, we will see the diagram. So if you have to draw the diagram for this one, you will be doing it this way. So I hope I can draw with the mouse. Usually I don't draw with the mouse, but let me show here. This is 13 and you will have the LED connected with the short pin and the long pin. So the long pin, you will connect it to this one, and the short pin, you can connect using the resistor and you can put it to the ground. So you will write here G, N, T. And that's it, very simple one. But we will see how the diagram turns out to be when we move ahead. Now in here, we don't draw the breadboard because it's understood. Well, when we come to the Arduino, the Tinkercad or in the lab, you are supposed to draw the breadboard. So this is assumed that it's in the breadboard. Now, yeah, coming back. This is simple. You can do it now I think maybe in like 2-3 minutes. And do you see something blinking within the board? Here. If you're using the 13th pin, and if you are grounding it, the left pin, which is the short one, to the ground, you can see a LED blink here. So let me take to that one. Hope it's this. No. Okay, I will change it here. So if you use the, okay, suppose you see I'm having the pin diagram here, which is at 7. This diagram is wrong. This was my trial. This one is to the ground. That is to the ground. How do I, but I have to put the resistor to connect it to the ground. So I connect it here and then from there to the ground. So if I have to make the connections in the grid, I have to put it in the black color. And this pin number 13. And let me put it, black is usually for the ground. So let me put another color like green. So positive, the anode is to the ground. And this ground is to the ground. We can just make it use the ground with the 13. You can even use the other one, but here I'm just, yes, you can make the lines straight later. So here I'm using the 13 pin and the ground. But if I do that, do I have to change in the code? I have to make it here 13. Because if I put 7 here, it's not going to work. And did I configure it as the output? Yes. But if I have to have the low state first, I have to put low first and high second. And delete the comments because it's saying as 8, but now I'm making it as 13. So let's see. Oh, it's not working? Yeah, it's working. The delay is too much. So let me make 1. We can't go wrong in the first one. I'll make it 400. Easy to see. Can you see something blinking in here also? This is what I wanted to show. So this is like within the board, there is an LED. So it has some inbuilt functions also. Now, if we configure this 13th pin as an output, it can be to an LED or any device. If we use this 13 as the output pin to any electronic circuit device or component, this would blink. It's just like a testing if this circuit is complete, like this 13 and the ground. So if this circuit is complete, this inbuilt LED will blink. Okay. So very easy, yes. So that's what I just want to show, like it's an inbuilt LED and it is meant for testing purpose. So within the board, we saw some LED and what pin do we use? This 13 and the ground near to it. And we can see this LED blink, which is an inbuilt one. Okay, so we have the code again, like just what do you do in the setup? You set it up as the output or input pin, and then you do the functions inside the loop. Now, we are introducing a new component called as push button. So push button means it just not go from on to off or off to on after a delay. It would go only from off to on if you push a button. So you see the code? If digital read is high, this means if the button is pushed, then the LED will blink, else the LED will not blink. So can you drag and drop a push button to the in between? You see, there is a gap in between. So usually the push buttons are placed in this way. They're not kept it here. It will not work. You have to put it in the middle. So you have a separator line in between. You have to put it in the middle. This is already existing. This LED is already existing. You have nothing to do with it. Just put it there. We are going to control it now with the push button. Am I fast? Okay, so you will keep a push button, and this is how you should connect the push button. You will take the diagonal points. So if you go with the top left, then you have to go with the bottom right. So top left, just like, okay, for the top left, connect to the VCC, the 5 volt, and the bottom right, you connect to any pin that will give the digital value. Let's see how it's configured. Let's see. So connect it this way. Connect one endpoint top to the VCC and other to one digital pin. And you should also keep a resistor there. And that resistor, so every push button should have this kind of working. So if you press it, the LED should turn on. Then this is the way of connecting. Like diagonal top, you connect to the VCC. Right bottom, you connect to the pin. And that same which you connect to the board should also be grounded. And that function is called as the pull down resistor. Now, let's go back to the circuit that I did. I think I have it. That one. Yes, my dear. This one, yeah, we have to put it. We have to put it. So this is what we are doing. We have the LED connected circuit from the second example. Now we have the push button, which we are going to add because we want to control the LED using the push button. We are adding more features to the basic circuit. So you guys can understand or not? It's difficult? It's confusing? A bit. Can do it? Code because your code is just for the LED blink on and off. There is no control with the push button. If you need to control with the push button, you have to add a new line of code called as if. If the push button is pressed, then the lights should turn on, otherwise turn it off. So that should be the new set of code. The code that you used for the previous one, you cannot do it here because if you do that here, it's just for the LED to blink on and off. If you bring the push button, you have to add the line in the code saying that push button has some effect on it. So here, if digital read of 2 is high, which means if the button is pushed, then the light should blink. That means the digital write means that pin should be high. So digital read is with the push button. It's reading what the push button is giving. So if the button is pushed, what will happen? the 5 volt from there is reaching the 2. The 5 volt, which is given in the top line, is reaching the 2. So if button is pushed, then what should it read at 2? High. So if the button is pushed, means at 2 you get a high. Then the pin at 13, which has the LED, should be high. So this means digital read 2 equal to high means you're pushing the button. So the 5 volt from there will reach the 2 using this line. 5 volt from the top reaches the pin 2. If you push, there is a contact made, and at 2 you get the high. In that case, what should the LED do? Blink. Digital, right? The LED is at 13. This 13 is from this 13. Is it okay? Can understand or not? Somewhat. Yeah. So you see here, our original circuit, we started with the LED. So LED is now connected to pin 13. This is the positive. Pin 13 will send the signal to the LED and it will complete the circuit this way. So this is the output. 13 pin is defined as the output. Now, second pin is defined as the input. But why? It receives the signal from there here. So signal is coming from there to here. So this is said as the input. If this is the input and this is pressed, this 13 pin should send the signal and complete that circuit. Then this is pressed. The 5 volt or similar high voltage would come from there and reach 2. Input 2 is receiving input. If it is high, if 2 is receiving a high signal, then 13 is defined as the output. It goes. It completes the loop of the LED and the LED blinks. If it is not pressed, what is reaching to? Low. Because this cannot come through. If it's pressed, then it can come through and make it a high. If it is not pressed, nothing can come here. It is low. If this is low, it will not send a signal to the LED. It is not blinking. If it is pressed, this comes here using this red line. High, LED blinks. Low, LED doesn't blink. So who is controlling here? The push button. Makes sense? Yes? Oh, but if you want to keep it on, you can press the shift and push the button. It will stay on.
Slide switch.
Again,
It won't be the same code. No, it's the same code. This plus shift.
Shift. Press the shift and click in the push button. The LED.
But if we want to do it with the circuit itself, we'll use the component slide switch.
Again,
Can use the component slide switch to make it. We can make it permanent and press the other time. Sure. This slide switch. It's just a switch inside of a button.
so exactly don't know how it will function, but you can just press the shift and click the push button. It will work. It will just show. We have many functions coming. Yeah, by the code also. Yeah, that's coming. Once pushed, that's coming, I think, in the next, after the next. Once it's pushed, it has to stay. It depends on the code. Here we say, if it is high, make it low. Or else, if it is high, make it high. Otherwise, make it low. We will see again the different kinds of circuits. So let's go back and move forward. Now, yeah, we saw this. And this is how it would look like in the normal circuit. You will have a push button and you see the top right would be connected to the VCC and the right bottom would be to the ground and then would be to the 2 also. So this is how your normal circuit would look like. Now, again, the repeating so that this line of code means it reads the digital state of the input pin. So it reads what is coming to it. That's what the new line of code we saw does. Now we see another component, which is called as the potentiometer. Or in short, you can call it the POT, P-O-T. So potentiometer, we are going to connect it to the board to make the LED blink again. So now we had the push button. Instead of the push button, we are going to use the potentiometer. Let's see what it does. So if the LED is on, there is a potentiometer in the circuit. We will see what it gives. It gives the delay. The potentiometer defines the delay. After the defined delay, it turns on. It's like off to on. So this has to be off. I copy pasted it, that's why. So this is off, and this has to be the low. Now, or the other way around. So here it follows high to low. So it has to be high and then low. So let me make it on. This is high, and then it goes to the low. So it defines according to the question. I'm sorry. So this is off, and this is low. So let's see what the pot is. In the lab, you can see the pot this way. So you will turn this like you, in the olden days, we turn the regulator of the fan or some knob, which you turn like this, like in the volume. So this would be turning, and you will have like 3 output to it. So let's see the picture, and we will come back and read this one. Okay, so this is how the circuit would look like. You are going to control the LED with the pot or potentiometer. So this is how you will see the pot in the Tinkercad. So it will have 3 pins: the left pin, the middle pin, and the right. So let's look at the Tinkercad, the first one. So you see, it's terminal 1. They call the middle one the wiper. The last one, they call it as the terminal 2. So what they call the middle one? Wiper. And you can drag it from here and connect it. Now, let's look what this pot does. So here you have to know like what each component does as well. So let's see what a potentiometer is. I said like we can turn the knob here, and it would go to the left, and then it would come to the right as well. So when it is in the left down, we say it is the low resistance setting. The resistance is less. Now, when it's in the right side, we can call it as the high resistance setting. But actually, what does it do? You see, it has a pin at 2 ends, terminal 1 and terminal 2, and there is a wiper, the middle pin. So the potentiometer works as a voltage divider. One end of the pin would be connected to 0, the other would be 5 volt. So if the pin is to the left, it would be in between those values. Like it would start from 0. If it is in the middle, you will get 2.5. If it is in the far end, you will get the 5 volt. So potentiometer means it can have variable resistance. That's it. Let's see. A pot. And if the, let me go here. You see, you have a variable end. Oh, I moved it. This one, this bar, if you try to simulate, I hope it's the right one. If you try to simulate, you can change this one from the left to the right. So this is like a wiper. At this point, you get 0 volt. As you move, like you move from the 0 to the 5 volt. So one end is to the ground, the other end is to the 5 volt. And in the middle, as you move the wiper, you get any of those values. Now, this is a analog reading device. It's not a digital device, it's an analog device. So we will connect it to the analog pin. So that's what I just want to say here. So here is your port. You have 3 terminals, terminal 1, wiper, and terminal 2. The left is connected to the ground, the right is connected to the power, and the middle pin, which is the wiper, is connected to the analog in of the Arduino. So this Arduino board, it would convert the voltage which is given by the port to a digital value. So the port would give a voltage value. It's analog. And the Arduino board, it has a ADC. You know what is an ADC? Analog to digital conversion. So each of the voltage is converted to a digital value by the board. It has a ADC within. I hope you have heard this in the first 2 lectures, that this board has memory, this board has the converters. So this board has the ADC also, which converts the analog signals to digital signals. And it is a 10-bit ADC. So the minimum value is 0. The last value is 1023. Now, how do you get this? 2 raised to 10 minus 1, because we start at 0. 2 raised to 10 is 1024. Because we start at 0, not at 1, the maximum value of digital value it could give is 1023. So that's the highest resistance value. Lowest resistance, middle position you get, this is the digital value of the resistance. Now, why do we need the port here? Like, we move the port, the LED will blink in one speed. We move the port to the other end, the LED's blinking speed can be controlled. So let me think, yeah, this one. So you can also search for this device. Well, let's see if, first let's see, and then you can try the code later. So this is in the minimum position. See what's the voltage? 0. Now, if I make the port come to the far end, it's going to be 5. So using this port, I can choose my resistance. I don't have to every time, okay, let me take the resistance. No, I can use the port and have the variable resistance. And I do that by changing the voltage. And as I change this, do you see the LED blinking slower or faster? This is less resistance. It's blinking fast. Now, if I move up, its blinking speed reduces. So this is one simple application of controlling the blinking speed of the LED using a potentiometer. Now, this device, you can just search in here for the multimeter. You can get it. And when you place it, you will see 2 nodes here. Black goes to the ground. Red goes to the wiper central terminal. Now, the wiper center one should be given to the analog one, because this is an analog component, not a digital one. The board will convert the analog value to a digital value. And based on that, the LED is blinking. Now, the circuit is fine. Do we miss something? The code. We have to show it in the code. We can say it in words and okay, but we have to show in the code. So pin mode A0 is the input, A0 is the input, because it receives the analog value from the wiper center terminal of the port. Now pin 13 is configured as the output, because that is where we connect the LED. So you see here, we can define the port as the input. You're not listening? You can understand? Okay, so it's the input or the output. We can do it using the void setup. In the loop, how do we start? We first receive the value. We have to convert it to the digital value. Now, this line does it. Sensor value equal to analog read. So we are getting the digital value from this line of the code. Sensor value means it's the digital value. Analog read function, analog read like the two bracket, inside that we have the A0. So whatever analog reading you get is converted to digital using this function. And it is stored in the variable sensor value. So analog read takes the A0 and converts to the digital value, and that value is stored in the variable sensor value. So you get some value analog reading from here. It goes to the A0 pin, and here you have the inbuilt ADC. So there has to be a function in here, and that function in here is this analog read, which converts the analog reading to the digital reading. This is something new that we are seeing now. So this does the ADC conversion, and it is stored in sensor value. So it can be X or Y. Well, this is something that decides how fast the LED blinks. See, where do we define it? In the delay. So based on the converted value, the LED blinks. So that's why when we turn it, the delay is decided by the analog reading. So the analog reading comes from the port all the way to A0. A0 does the conversion, and that converted value is given as the delay for the blinking. That converted digital value is given as the delay for the blinking. So as you move the port, the LED blinks faster or slower because this analog value comes to the A0. Here it's converted to a digital value, and that is defined as the delay. So as there is less resistance, the LED blinks faster because this is actually the delay. So potentiometer is causing the blinking speed or the delay here. Understand? So we started from the LED blink, we used the push button, and then we used the port to control the LED. We started all the way from normal LEDs, then we used a push button, then we used a port. Well, to say these are the symbol circuits and these are the symbol ports. We are going to level up very soon. Okay. So feel that this is the simple ones. These are not the hard ones, very simple ones. Okay, so what affects the blinking speed? The value in the port, potentiometer, yeah, the voltage. But it has to be converted to the digital. So this function converts in the range of this. Like it can be a digital value from 0 to 1020. And that is given as the delay. And that determines how fast the LED should blink. Now, let's move to the next one. So this is how we started from here. We came back here. So if it was in the lab, you would have done this. But we did in the circuit. You can do it later. And while you do it later, if you find any difficulty, just let me know in the Teams. I will be happy to help. Now, it's again with the port. We know what a port is now. It has a wiper, so we can select any of the voltage. So this is like a variable resistor, not a fixed resistor. This is a variable resistor. And We all saw this again, like there are this many analog pins. And this was one of the questions in the assignment, like how many analog pins you have. So now we are familiar to it, how many analog pins it has, how many digital pins it has. We started seeing the board. Now, again, the analog read would convert the analog value to a digital value. Now, you see, we are using two new lines of code, serial print and serial print in line. So why we use this? Serial print means we will print this line, like in the normal language of print. We will print this line, and print ln means continuing in the same line, like the value of x is something, it would print the x value along with the line. So we will see the output in the Tinkercad if you give this two lines. We will see how it's done. We will come back here again. So this is something, again, we know it's repeating. So we have to move to the code. It's almost finished. Let me see where I have done it. It's not done by me. So I think it's here. Let's see the code. Yes, you see, this is called as the serial monitor. Can you also take that? And you see the same line, the value of x is, and it gives a number. So this is the value of x is given by this line, serial print. Now, if you give serial print ln, it prints along with the previous line. Now this is running. It's running for a minute now. And if I vary the potentiometer, you see, this is the digital reading. So what do I do with these two lines? I am printing the value in the serial monitor. So these words should be familiar to you. Like, where do you print the value, or where do you see the results? In the serial monitor. And what are you printing it here? The digital value of what the potentiometer is reading. And this is the delay that you would be giving to the LED for blinking. So these two lines, two new lines, serial print, it would print until here, the value of x. But to give the number along with it, you have to give the serial print ln x. So this would be given here. Now, what is this x? It is the converted value, the digital value.
Serial would begin.
Serial print.
Start begin.
Oh, okay. So this is here, we define this. This is called as the baud rate, BAUD. We can define it, we cannot define it. But usually, if we define, like for the practical case, when you do the hands-on, you define the rate for which your board has to work, the Arduino board, like a frequency, baud, BAUD. So it's something that it's fixed for the board. For each board, this changes. So for the Uno, it's 9,600. And we can use that for, usually in the lab, we use it for the printing, because there you have another screen. So the printing rate should match the frequency or the baud rate of the board. BAUD is this one. So you can merge this reading along with the LED blink. You can combine two experiments. So this is just printing the digital value in the serial monitor using the serial print and serial print ln functions. You can combine along with the LED blinking for this experiment. So this, we saw that we can print values in the serial monitor. And these are the functions that we use. Now, example 6. It's quite a big number of examples that we are seeing today. We will see this again, but in a more practical way, we will be seeing this. For today, what you are expected is to do is in the lab, you will be seeing these boards, these circuits. So you need to know, like, okay, I have seen this, I have seen this. We will do this again. Okay, we will do this, like spend at least half an hour in the coming classes. You will do practice questions again in the class. For now, this is just like bringing you to what we are going to do. This is all introduction. We'll be seeing much heavier questions. So, another example, motor on and off using a push button. So, this one is actually a mini version of what you will do in the lab today. So, the lab is guided by the engineers. So, you will see somewhat similar one in the lab, but with additional components, because you can design in the system with no protection for the board. It's fine. But when you come to the lab, you will have to be serious that you don't burn your things out. So there will be some additional components that you add in the lab. That's because you're doing it practically and you don't want to burn your LEDs or boards. Well, in the simulation, those things we can keep it aside. But I will tell you what those are as well. So this is motor on or off using a push button. So you have a motor which is running. When you push, motor turns on. When the button is released, motor is off. So how many different components we saw today? The LED, potentiometer, push button. Now we are going to see the next component, which is motor and a push button. Motor is the new one. So this is how a motor would look like. Let me make it a bit bigger. Okay, so this is the motor, DC motor or the motor. Now we are going to control it with a push button. So you know how to give the push button control now. The top left to the VCC and the top below right to whichever port that you want to. But the same port should be connected to the ground by a resistor. So this is the normal connection way for a push button. And you know that the black line, you should always connect to the ground. The red line, you will be connecting the VCC. And you can even like extend it to the top ground and VCC if you have some connections over there. So what's the new thing? The motor. It's very simple to implement. If you drag and drop, you can see 2 pins for the motor. What's one? The black. What's the other? Red. Black goes to the black, the ground. Now the red, it's something where we should give the input. So we have the resistor, and through the resistor, we give the input from 3 and then make the motor work. So you see, button is pressing. Motor should work. So if I have to make the motor work, I have to give something to the motor or get something from the motor. Okay. If I want to make the laptop work, I have to get something from the laptop or give something to the laptop. Give. So if I want to make the motor work, I have to give something to the motor. So you see, the motor should be the output. Now, who is deciding the motor should work or not? The button. So the decision comes from the button. So button decides. So the input is going to the board from the button, and something is given to the motor, and the motor is pin. That pin is defined as the output. You see, now I'm not putting like 2 and 3 within. So we saw some few problems, and now we are in the state that we can define it this way. Integer. Integer motor equal to 3 means which pin I'm connecting the motor. It's integer. Integer button equal to 2 means which pin I'm connecting the button to. Now, you see, I'm connecting the motor to the 3 because it's kind of analog, yes? So it has some kind of analog support. So when it is like the motor or the pod, I will choose this one. But pod specifically, it's giving the input. So analog in has to be chosen. If it is the pod, we will be choosing the analog in because it's from there, the input. Now it is to that. The motor means it's to the motor output. So I can choose the 3. So think it this way. If you have a motor and a push button, the push button is the input, the motor gets the output and it will turn. Now, when should the motor turn? This we saw before with the buttons. This come with the button. Digital read is 1. So if the digital read is 1 means if the button is pressed, the motor should turn. The button is released, the motor should not turn. It's easy to say in words, but when it comes to coding, you have to know. Like these are the common things that you see. Digital write, digital read. So when it comes with a button, we often use digital read. When you have to make a pin low or high, you have to use digital write. Now, we are going to be advancing very soon. So I'll give you a few minutes to look at it. And if you can, I think within the PDF, you might have a link. If you click on that link, you can go to the circuit, I hope. Can you check if you have downloaded the PDF from the Blackboard? Try to click in the link. Can you? Because if I click, I'm again going to my own dashboard. Try to click, no?
Sorry, mistake.
I have to see how I can efficiently share it. Okay. It's the link that I'm sharing, but it says like it's not valid. Let me search from here. Again? Project folder. Okay, I will say it. Can you just remind me in Teams? Once I leave the class, I'll be very happy and I forget. So just tell me that I can create a project folder. I will be happy to do that. Okay. Okay. So this is the button controlled motor. Yes, push button. I hope I didn't click anything stupid. It's coming at this time? For this long? Yeah, it's this one. So I hope you can find the motor from here, the push button, which is again here, do the connection. So we will do the circuits, which is important for our course together. Don't be devastated or don't be sad that I'm not making you do anything in the class. We will do it. We will do the ones relevant to the course in the class. This is just a bit much called as a preparatory step. So what is needed for the exam? What is needed for the class? You have to bring your laptop and you have to do in the class. So this is how the circuit would look like. The push button, the DC motor, and you would put the code here. So you can put the code here. So this is a bit higher version of the code. We will come to that. It's updated. So let me put this code. We will see. We will see. For now, how does it work? You push the button, motor turns. You leave the button, motor doesn't turn. Let's move to the next one. So are we specifying the speed of the motor in this question? We can just push the button, turn the motor off. Leave it by leaving the button, it's off. Press, it's on. But can we control the speed also? Yes. With this, we will stop. So example 7 is it's push button, turning on and off a motor, but we are going to specify a speed. One point to note, in the lab, when you do the DC motor question, you will need a transistor. So transistor, and sometimes you might also use a diode, because this is for the protection of the motor as well as the board. So as you go, did you receive the lab manual? No. So in the lab, you can't just directly connect your motor this way. You have to have like two additional components, which is called as the transistor and a diode, a flyback diode or just a diode. So you need to add those to protect your motor and the board. Well, you will see much detailed in the lab, but we will again, I assure you, we will study back in the class also those. And the next time we go to the lab, we'll be sure of what we are going to do. It was a very fast decision from the engineer, so I had to agree to it. I cannot say no. So we will do it. Don't worry. You will learn more practical in the lab as well. So here, this is the official question. You see, this is how your question will be given for doing. Till now, the question was unseen. We were just looking. This is the question. See, you will be asked to design an embedded system, draw the state chart, hardware schematic, and code. Now they are saying a mechanical, right? So this is the application, and we are going to design an embedded system. And they say plenty of conditions. What do we start with? State chart. Then we draw the hardware schematic, and then we will write the code. So this is how the question will look like. I think you have seen the similar one in your assignment also, a big one. So this is how the question is. And now we have some idea about the components, about the connection, and we will do it. So first, the state diagram. So this is the standard components that you will have for the questions that you get for the exam, for the assignment, etc. From this, you will choose what you need to. So in this question, what do they say? You need a motor and a push button. So from this, we choose motor, it's an output. So it's not the server, it's the push button that should be selected. The push button, it's the input. And then we define what those are. If the motor is the output, if motor output, if it is digital, these are the two states. If it is analog, it is the rotational speed. Now, push button is the input that will decide the motor has to turn on or off. It's usually on, off. There is no analog option. But for the motor, it can be on or off. We will see what that actually means. Just pay attention to here. Motor can be digital and analog. We will see what that actually means. So here, in this question, they are defining the speed. So here we will choose the analog option, but we will also see what this digital means. Digital means the motor is on, the motor is off. When it is on, it works at full speed. That is what is meant by digital, on, off. There is no other option. So digital means you either turn the motor on or the motor off. But if you're going for the analog one, what additional benefit you have? The speed you can control. So if it is just like a push button, motor on, motor off, there is no speed control. But if you want to do it as a specific speed, you will choose the analog option. So happy that you understood that much. Now we know, like motor we are choosing, and we are also choosing the push button. We know those are the two components. And now we are starting the state diagram. So what does the question say? The mechanical ride is in the off state when it is powered on. So what can we draw from that? The black dot and the off state. Then we read again. In the off state, the motor is not working. Okay. If the button is pushed, the mechanical ride goes from the off state to the on state. So what is the next state? The on state. So in this step, we will identify how many states are needed and what is the first state. On. The second one, I'm sorry, first one is off, the second is on. Now, we also know like the motor is not working. What is the speed? 0. But when the motor is on, the speed they want is 50. We are designing step by step. Analog, yes. If they don't specify, digital. Here they specify the speed, we are going with the analog option. Now, when does this transition occur? Only if the button is pushed. If it is not pushed, the transition doesn't occur. And when should it go back? After 20 seconds. Is it like the button release? No. We push the button once and after 20 seconds, it can go back. So you see how it's happening. Like additional features, additional lines are coming in. Now, we have time. 3:30 is the last. Yes, we have time. So these pins support PWM or the analog write. Which are the pins that supports the analog write? The ones which has the tildes. So we have seen this before. Just like saying it in between. These points or these pins 3, 5, 6, 9, 10, 11, which has the tilde will support the analog ones. Now let's move to the next one. I have to make it big. So you see, we have the motor, we have the push button. This circuit remains the same, but we are going to make it have the analog capability or have the capability of adjusting the speed. So let's read through the code, but first just look at it. Digital write motor pin high means this is digital control. You can set as high or low. But if we write something which is hidden behind analog write, you can specify the 50% speed. So just look for this one. If it is digital write, what would be the motor speed? 100 speed, full speed. But do we need that? We need the analog one. Like we should put actually this one, analog write motor 127. This is the 50% speed option. So if you put the digital write, it is motor on, motor off. We will look at the what's written before and after. We will see. If it
is always up.
okay, from 0 to 255, it's like the range. If you want 50%, it's the half of it. If they say 30%, then you have to adjust the value accordingly. 127 is the middle.
So what speed is always up?
The range.
Yeah.
If it is digital, 255, like it's the highest speed. Digital means you run at the 100% speed. 100% speed, not 50%. But if you want for the 50%, you have to go for the analog write option. Digital write means you can either choose 0 or 100. Analog means you can choose the speed that you need. Is it okay? And if you choose the analog, you have to use the pins 3, 5, 6, 9, 10 or 11. Okay? You cannot choose any other pins without the tildes. So you have to use the pins with these tildes to get the analog write option to make your motor go at 50% speed. If you just put this line, your motor will go at 100% speed. You can use these pins, you cannot use, it's fine. But if you need the analog, you have to use these pin numbers. Okay. Now, so this is just the motor is switched on. But if you put this one, it will run at the 50% speed. Now, why is it from 0 to 255? Why not from 0 to some other value? So in the board, this is the resolution. It uses a 8-bit pulse width modulation resolution. So what is 2 raised to 8? 256. So it's like what do you say, specification. So there is like 256 values with this board. So it can have from 0 to 255. And if you choose the 50%, this should be the value that you give to the analog write. Am I clear? So yeah, the same code, the same figure, but this line, instead of making the digital write, which is just push button, motor on off, I am doing motor at 50% speed. If it is push button, motor on off, I can use the digital write. Okay. So this is the question that you will be facing in the exam. Like this is the standard question. So you should know if your speed has to be adjusted, it has to be analog write and not digital write. Digital write has two options, on, off. It's like high, low.
Instead of 50 or 100. So we will do 5, we'll take the 50% of 255, then we'll put the value instead of 127 here.
Yes. So now what we were trying to do? We started with off, push button press. We know how to do the 50% now. Now after that, the push button can do whatever it wants, but we have to go back to the off state after 20 seconds. That is how we are going to design the problem. So now let's look at the code. So we said, okay, the motor pin is 3, which is here, which is the analog pin. We need that. Now button, it's digital always. So we can choose 2 or any. But if it is a motor, you have to go with the tilde ones, the PWM support ones, enabled ones. Now you see, we have to have that 20-second delay. So we have to count when the motor starts, and after 20 seconds, it has to stop. So we have to count when the push button is pressed. After 20 seconds, it has to go back to the off state. So it might look a bit new because it's new. It might feel a bit rough because it's new, but you will be used to this after today. So we have to count when we are starting. So that is this one. And how do we define it? Usually for this count of like time, this one is usually defined at unsigned long. Why unsigned? Because time doesn't have a sign. Now, anyway, as you progress during the code or during the simulation, the time or the negative sign should not affect it. So safe in case of time, and when you are counting something, this is how you will define it. Unsigned, unsigned. This is the start time. And what is the run time? The 20 seconds that we are going to design. And it should be 20 seconds and it should not get affected by anything else. So we define it, by the way, constant. You see, this is unsigned long, the starting value. The value that we say 20 seconds, we are defining it here is equal to 20. Forget the UL. I'll tell what UL is. So both of them, we are defining it, by the way, unsigned long. So when you are dealing with time, you will be defining it in the way unsigned long. This is the start. Like it is 0 because that's where you start the time. Now, runtime means the 20 seconds. So you have to define it, by the way, constant. It should not change. It's a constant for the whole coding or the program. Now, this we know. Button pin is the input, motor pin is the output. Now, we can have a look at this later, but button pin is the input, motor pin is the output. Okay, now if the digital read button pin is high, which means digital read button pin means button is pressed and the motor start time is 0. Yes, we are going to start. We can't see it. Yes. So we are defining it. The pins, we define the motor start time and the run time, and we are defining the button pin and motor pin. And now we are defining the loop. In the loop, we say if the button is pressed, which means digital read button pin high and the motor is about to start, Now we are defining a new variable. You say millis. What is millis? It counts time. It's like tick, tick, 1, tick, tick, 2. It counts the time. So motor start time, record the turn on time. New functions, new variables. We will be used to it. For now, just accept. Like you are getting a new friend and you're not still used to talking to him. Watch. And then you will be feel free to use it. Millis. So MILLIS. So it will record the turn on time. And this one, as we know, we will be using this one because we want the speed control. Now, if motor is on and runtime has elapsed, what is runtime? The 20 seconds. So if the motor has started and the runtime is reached, then your digital write motor pin, here you can write the analog motor pin. You can define the value 0. If you write here digital write, here also you will have to write analog write and your value has to be 0. Digital you write high-low, analog you write in now. Digital you write high-low, analog you write in numbers. Everybody is like watching me and she's saying so much of things. She was not teaching the last week and now she's teaching too much of things. Last week, some students were not there. Some students has joined now. So it was introduction. Well, this is the real class and we will see this again and again until we are done. So we define the pin and because we are dealing with time and again, if we deal with time, this is how we will define it. And we know how we will define the pin. This is how we usually start, but this is apart from it. And then we said, okay, if the button is pressed and the motor start at 0, count it. Okay, until you count up to 20, make the motor run at 50% speed. And after your count reaches the 20 seconds, turn off the motor. So this is what each of the lines says. And you see this UL, it is like the unsigned long again, UL. UL. You can define it with it, you can define without it, but to be on the safe side, whenever you define the time, you can make it UL to match it with this, and there is no like bugs or problems within. You're feeling difficult because it's the first time, and
All combined together.
always the first class is difficult when you see new things. This is not difficult. Actually, this is not at all. If you, okay, imagine, I have a small, like, imagine, okay, imagine. I have a small kid and I say, you are bad, you are bad, you are bad. I tell that to it like 10 times, you are bad. Finally, it will feel for itself, yes, I'm bad. So you have to say, it's easy. And then you will feel it's easy. Well, it is easy. Well, the kid is also good. So you have to just try. And it's, if someone else can do it, I can also do it. That should be in your mind. If he can do it, I can also do it. It's not undoable. Maybe you'll have to spend some time on it, but it's still doable. There is nothing to be panicked of. The Tinkercad is freely giving all these lectures. They have all the codes. Just go to Google and type motor with push button. It will give you the circuit with the code. So you see, sometimes you don't have to do anything, but you have to just know. For the exam, you can't just go for the existing template. You have to write it. So study materials are available anywhere. For example, let me show you. If you want to have a practice. Yeah, I have to leave you right now. But please come back because I haven't marked the attendance. One thing. Wait.
You have to build that up and come back here.
Oh my God, I have to take the attendance. I'm trying to skip it. Okay. Can you write in the paper? Because I am going to take a while. And for the online students, let me have a look. No, there are so many of you. Actually, can just the aligned students raise up their hand so that I make a screenshot of your names and I can mark you? Just the aligned students. So 1, 2, 3. I think there are 7 of you. Yes. So today, 1. Okay, 5 of you. Just 5 of you. Shamsa, Abdul Rahman. Okay, 6 of you. Wait, let me take a screenshot. So it's just 6 of you. The 7th, Shamsa, is not from the Alain branch. So I'm marking the attendance, and I hope that you have talked with the engineer for the lab. Okay. Okay. So I hope you have talked with the engineer in the lab, and you might have known how to do your practical section. Yes? Can someone reply?
Yes, doctor. Actually, the lab is like after 5 minutes.
Okay, okay. Okay, so you will be joining online, yes?
For the lab, no.
Or the lab
You're
is
talking
going to
about the
be,
lab or what?
yeah, about the lab, yes.
No, no, we have it online.
Okay, okay, lab will be hands-on, okay.
Yes.
So when is it like in the coming Thursday?
Come again, what?
So you have the lab on Thursday.
No, no, today.
Today,
On Tuesday.
okay, okay, the same
Yeah.
time, okay, okay.
No,
Yeah,
no,
same
after
time.
5 minutes, doctor.
Okay, okay, bye, thank you, and all the best, bye.
Thank you, doctor.